Hello everyone, I hope you all are doing fine. My name is Moinak and this is the third part of a 4-part series of Wbpsc Assistant Engineer Civil 2014 paper. In this video, I have tried my best to explain each and every solution in details, and also the connected questions that might be asked from a particular section is also discussed in details. So if you're new to this channel and if you like the content that I'm making, do subscribe and share this video with your friends who are preparing for civil engineering government exams. So without wasting any more time, let's start with the questions. First question of today is radius of equivalent circular contact area of a dual wheel for a 80 kN single axle load with contact pressure of 552 kPa is. Now for a dual wheel assembly, the load is 80 kN. So for a single wheel, the load would be divided by 2, which comes out to be as 40 kN. Now the contact pressure is given as 552 kPa or 552 kN per meter square. You know the contact pressure is given by load upon area, or the area is given as load upon contact pressure, which comes out to be as 0.072 meter square. Now if we equate the area with pi r square, the r value would come out to be as 151 millimeter, which is your answer. Now you can also solve this particular numerical by this particular formula, where A is equal to root over P by pi P, where capital P is in kg and it is the load, small p is the contact pressure which is in kilogram per meter centimeter square, and A is the radius of equivalent circular area in centimeter. So if you replace the values and if you convert the units to kg and kg per centimeter square, then the radius of equivalent circular area would come out to be as 15.18 centimeter or 151.8 millimeter. So the nearest answer for this particular question should be 152 millimeter. You can solve this numerical in both the ways. Next question is a 30 centimeter square bearing plate settles by 1.5 centimeter in a plate load test on a cohesive soil when the intensity of loading is 2 kg per centimeter square. The settlement of a prototype shallow footing 1 meter square under the same intensity of loading is. Now a very simple formula is used for this particular numerical. For cohesive soil, the SF by SP is equal to BF by BP, where SF is the settlement of foundation, SP is the settlement of plate, BF is the width of foundation and BP is the width of plate. And we need to find out the settlement of foundation. We just need to replace the values of BF, BP and SP, and the result would come out to be as 0.05 meter or 5 centimeter. So the settlement of foundation according to this particular question is 5 centimeter. Also for cohesionless soil, this particular formula is used. And this might be useful for numericals as well. This might also be asked. Next question, in aerobic environment, nitrosomonas converts. Now in aerobic environment, nitrosomonas converts ammonia to nitrite and nitrobacter converts nitrite to nitrate. Remember this. And also paracoccus, it converts nitrate to nitrogen gas. But this is in anaerobic conditions. And nitrosomonas and nitrobacter converts this in aerobic conditions. So for this particular question, the answer should be in aerobic environment, nitrosomonas converts ammonia to nitrite. Next question is Baird and Foster's method for determination of ESWL is based on. Now equivalent single wheel load is the single wheel load having same contact pressure which produces same value of maximum stress, deflection, tensile stress or contact pressure at the desired depth. Baird and Foster's method, which is a semi-rational method, is used to find ESWL based on the following assumptions. Now these assumptions are important. The assumptions are, it is based on equal stress, the contact area is circular, the influence angle is 45 degree, and the soil medium is elastic, homogeneous and isotropic half space. So for this particular question, the answer should be Baird and Foster's method for determination of ESWL is based on equal vertical stress criteria. Next question is, if the coefficient of permeability and that of percolation of a soil are 1 into 10 to the power minus 3 centimeter per second and 2 into 10 to the power minus 3 centimeter per second respectively, its void ratio is. Now you know the porosity value is given by coefficient of permeability by coefficient of percolation. Now if you replace the values, the value of porosity would come out to be as 0.5. And you also know void ratio and porosity is related as E is equal to N by 1 minus N. So if you replace the value of porosity, the void ratio would come out to be as 1. So the answer should be 1 for this particular question. The answer should be B. 1. Next question. A normally consolidated clay settles 1 centimeter when effective stress was increased from 100 to 200 kilonewton per meter square. If the effective stress is further increased from 200 to 400 kilonewton per meter square, then the settlement of the same clay is. Now, you know the settlement is given as del H is given as ssc-je naught by 1 plus E naught times log 10 of initial effective stress plus the change in effective stress divided by initial effective stress. Now you know this part ssc-je naught by 1 plus E naught for this particular question should be a constant because in both the situation same clay is used. So this part is a constant. So for the first part of the question, del H1 is given by C, which is a constant, times log to the base 10 of 200 by 100. Also in the second case, del H2 is given by the same constant C times log base 10 of 400 by 200. Now if we take the ratio of both del H1 by del H2, it comes out to be as log 2 in both the cases. So this cancels out, and del H1, you know, the value is 1 centimeter. So del H2 or the settlement in the second case is also 1 centimeter for this particular question. The answer for this particular question should be the settlement of the same clay for the second situation is also 1 centimeter. Next question is wet mix macadam is used for construction of. Now wet mix macadam is a pavement layer wherein the crushed graded aggregates and granular material like graded coarse sand is mixed with water in mixing plant and rolled to a dense mass on a prepared surface. It can be adopted for sub-base and base course. So the answer for this particular question should be A, sub-base and base course. It is actually an improvement of the WBM. It is an improvement of WBM, water-bound macadam. Next question is, if pan evaporation is denoted by EP and actual evaporation by EA, then. Now, you know, actual evaporation or lake evaporation is given by pan coefficient times the pan evaporation. Pan coefficient, which is Cp. Now, the pan coefficient value, it varies from 0.4 to 0.8 for class A pans, and it varies from 0.65 to 1.10 for IS pans. And the average value of pan coefficient is taken as 0.7 for class A pans and 0.8 for IS pans. So the pan coefficient varies from 0.7 to 0.8. From this, you can clearly understand that pan evaporation is always higher than the actual evaporation. So the pan evaporation is always higher than the actual evaporation. So the answer for this particular question should be A. EP is greater than EA. Next question, equivalent axle load factor defines. Equivalent axle load factor defines. Now equivalent axle load factor is the damage per pass to the pavement by the ith type of axle to the damage per pass of standard axle load. So the answer for this particular question should be C. Damage per pass to the pavement by the axle in question relative to the damage per pass of standard axle. So this is the EALF or the equivalent axle load factor. The next question, the specific yield of a soil depends on. Now what is specific yield? Specific yield is the volume of water drained by gravity drainage by the total volume. And it depends on the grain size and shape, the distribution of pores and the compaction of stratum. So it depends on all three. So the answer should be D, all the above. The answer should be D, all the above. Next question, if the total distributed load on purlin is W including wind load, the maximum bending moment is. Now, if the maximum bending moment in a purlin may be taken as WL by 10, where W is the total distributed load on purlin including wind load. So the answer should be D. The answer should be D. Next question, tranquil flow must always occur. Now, tranquil flow is more popularly known as subcritical flow. And this is a chart which you can take a screenshot of, and you should remember this chart. This is the type of flow, subcritical, critical or supercritical, and these are the parameters: energy, depth, velocity and Froude number. Now for subcritical flow, the energy is greater than the critical energy and the depth is greater than the critical depth. So for this particular question, the answer should be tranquil flow must always occur above critical depth. Also for subcritical flow, the velocity is less than the critical velocity and Froude number is less than 1. And for supercritical flow, the energy is again greater than the critical energy, the depth is less than the critical depth, and the velocity is greater than the critical velocity. Also the Froude number is greater than 1 for supercritical flow. So you should remember this chart as well. This is very important. Next question is, in which of the following types of flow the losses are maximum? Now remember, for turbulent cases, for turbulent flow the losses are maximum. Next question, in an open channel under critical depth, The answer for this particular question is specific energy is minimum. In an open channel and the critical depth, the specific energy is minimum. Also, at critical flow, specific energy and specific force is minimum for a given discharge. Also, the Froude number is equal to unity. Also, for a given specific energy, discharge is maximum at critical flow, and flow at critical state is unstable. This is very important. Flow at critical state is unstable. Next question is, the slenderness ratio of a single discontinuous strut shall not exceed. Now, for single discontinuous strut, the slenderness ratio should not exceed 180. This is as per IS 800. Should not exceed 180. Next question, sag rods in a roof truss are used for connecting. Now, this is an industrial building where the purlins, where the sag rods are, these are the sag rods, these are the sag rods which are used for connecting the purlins, so the answer for this particular question should be sag rods in a roof truss are used for connecting purlins. Also sag rods are designed for tensile forces only, remember this. Also, purlins are continuous members in industrial buildings which are not designed for wind load or earthquake load. These are not designed for wind load and earthquake load. Now these are the bracings, and bracings, these resist the wind load and earthquake load. So the answer for this particular question should be purlins. Sag rods in a roof truss are used for connecting purlins. Next question, a principal plane contains. Now a principal plane contains no shear stress. The answer should be no shear stress. Next question, a canal was designed to supply irrigation needs of 1200 hectares of land growing rice of 140 days base period, having a delta of 134 centimeter. If this canal is used to irrigate wheat of base period 128 days, having a delta of 52 centimeter, the area in hectares that can be irrigated is. Now, for this particular question, for rice, the area is given as 1200 hectares, the base period as 140 days, and the delta is 134 centimeter. You need to find the duty. You know delta is equal to 8.64 B by D. So D is equal to 8.64 B, which is 140, and delta here is 1.34 in meters. This is in meters. So the duty comes out to be as 902.69 hectares per cumex. Also, the discharge is calculated as A by D. You know area is 1200 hectares and the duty we have found out as 902.69. So the discharge comes out to be as 1.329 cumex. Also for wheat the base period is given as 120 days and delta is 52 centimeter. You need to find the duty again. So the duty comes out to be as 1993.8 hectare per cumex. Just replacing the values of B and delta in meters. Here you can find out the area by multiplying the discharge times the duty. You have already found out the discharge here as 131.329 cumex times 1993.8, which is the duty. So the answer for this particular question should be 2649.82 hectares. 2649.82 hectares, and the nearest option is A. 2650 hectares. You can also solve this particular numerical by this simple formula, where this is the area of rice in hectares, this is the delta of rice, and this is the base period of rice, which is equated to the area of wheat, the area that needs to be irrigated for wheat, the delta for wheat, and the base period for wheat. You know all the values except the area required to be irrigated for wheat. This you don't know, so you replacing all the values, you can easily find out the area required for wheat. So the answer for this particular question should be A. Next question is, percentage of more cement should be used while concreting underwater than that required for same mix placed in dry condition. So the percentage of cement that should be used while concreting underwater should be at least 10% more, or at the discretion of the engineer, than that required for the same mix placed in dry condition. So it should be at least 10%. So the answer for this particular question should be B. The next question is, an isochrone is a line on the basin map. Now an isochrone is a line on the basin map joining points having equal time of travel of surface runoff to the catchment outlet. Now an isochrone is also defined as a line drawn on a map connecting points at which something occurs or arrives at the same time. It is commonly used to depict areas of equal time travel. So the answer for this particular question should be C. Joining points having equal time of travel of surface runoff to the catchment outlet. Next question is the maximum value of centrifugal ratio on roads and railways respectively are taken as. Now centrifugal ratio is also known as impact ratio. Is also known as impact ratio, which is given by centrifugal force to the weight of vehicle. The weight of vehicle, and you know centrifugal force is given by mv square by r, and weight of vehicle is given by mg. By cancelling out, you get the centrifugal ratio or impact ratio given as v square by rg, right? You also know this E plus F is equal to the centrifugal ratio, where E is the super elevation and F is the lateral friction. So E for plane and rolling section, it is taken as 0.07, and F, the maximum value of F is taken as 0.15. You also know the value of maximum super elevation is taken as 0.10 for mountainous regions. So if you add E and F, the maximum values of E and F, the value would come out to be as 0.25 for roads. So the maximum centrifugal ratio for roads comes out to be as 0.25, and for railways it is 0.125. So the answer for this particular question is B. For roads it is 1.4, and for railways it is 1 by 8. 1 by 4 and 1 by 8. Next question, in a flow net diagram, the length of flow line in the square is 2 meter, the head loss is 18 meters, and the number of potential drops is 12. The value of exit gradient is. Now exit gradient is given by del H by L. Del H by L, where del H is the head loss across each field, and del H is given by H by NQ. Del H is given by H by NQ, where H is the total head loss and NQ is the number of potential drops. Here H is given as the head loss is given as 18 meters and the potential number of potential drops as 12. So the del H value here comes out to be as 1.5. Also the exit gradient is del H by L. Del H is 1.5 and the length is given as 2 meters. So the exit gradient comes out to be as 0.75. So the answer for this particular question should be 0.75. The answer for this particular question should be 0.75. Also, these are the flow lines. These are the flow lines that are depicted here. Also, orthogonal to that is known as equipotential lines. Orthogonal to flow lines are known as equipotential line, and this is a flow field. This is a flow field. This is a flow field, and the length of which was given in the question. Also, you should remember this formula. The discharge per unit width is given as K into H into NF by ND, where NF is the number of flow channels and ND is the number of equipotential drops. Now NF is given by number of flow lines minus 1 and ND is given by number of equipotential lines minus 1. Now the next question is minimum compressive strength of burnt clay bricks shall not be less than. Now for burnt clay bricks, the minimum compressive strength should be greater than 3.5 MPa. Should be greater than 3.5 MPa, and the nearest option here is D. Nearest option here is D. Also for first class bricks, it should be greater than 10.5 MPa, and for second class bricks, it should be greater than 7 MPa. Also, the water absorption for first class brick should not be greater than 20%, and for second class brick it should not be greater than 22%. These are also important. Next question is the ratio of average velocity to the maximum velocity for steady laminar flow in a circular pipe is. Now for a steady laminar flow in a circular pipe, the velocity distribution is shown here. Now the velocity distribution here is parabolic in shape, and the maximum velocity is given by this relation. Umax is equal to 1 by 4 mu times minus del p by del x times r square, and the average velocity is given by 1 by 8 mu times minus del p by del x times r square. So U average by Umax comes out to be as half or 0.5. So the answer for this particular question should be C. The answer for this particular question should be C. The next question is, if an upgrade of 1.5% followed by a downgrade of 0.5%, the rate of change of grade is 0.2% per 20 meter chain, then the length of vertical curve is. Now the upgrade here is 1.5% and the downgrade here is 0.5%. So the n value, the change in gradient is n1 minus n2. Here we are taking upgrade as positive and downgrade as negative. So if you equate, the change in gradient would be 2%, and the rate of change of grade is already given in the question. Now the length of curve is given by change of grade by rate of change of grade. So it comes out to be as 200 meters. So it comes out to be as 200 meters, and the answer should be A. The answer should be A. for this particular question. So this was the part 3 of a 4-part series of WBPSC 2014 Assistant Engineer Civil paper. I hope this is helpful for students who are preparing for this particular exam and other similar government exams as well in civil engineering. So if you like the content that I'm making, do subscribe and share this video with your friends who are preparing for similar exams. Stay safe everyone, stay home and study hard but study smart, and thank you.